Welcome to Study Loop.
Let's evaluate the given integral. So looking at the denominator, it's already factored, but that quadratic might factor into two linears. So we can look at this test down here given in the section. So a quadratic will not factor if b squared minus 4ac is negative. In our problem, we see that the a is 1, b is 0, and c is 1. So this tells us that b squared minus 4ac is minus 4, which is negative. So that quadratic x squared plus 1 does not factor. And we can go ahead and write the partial fraction decomposition using what the author calls case 4. This is where you have repeated quadratic terms in the denominator that do not factor. So the first term will be ax plus b up top, x squared plus 1 on the bottom. And then next time we'll have x squared plus 1 squared in the bottom. And then we'll have another linear up top, cx plus d. Let's go ahead and take this equation up here, multiply both sides by this x squared plus 1 squared, and we should get x squared plus x plus 1 on the left. And then on the right, ax plus b times x squared plus 1, and then plus cx plus d. And then let's just go ahead and simplify this. Ax cubed, bx squared, and then we'll have a ax, but then here we also have a cx. So let's write that as a plus c x. And then for the constant term, we'll have a b and a d. So b plus d. The reason for doing this is that we could find a 4x4 system of equations. On the left, we see that we have 0x cubed. So this means that 0 and a are equal. So let's write that over here, a equals 0. Now, in front of the x squared on the left, we see a 1. On the right, we see a b. So b has to be 1. In front of the x on the left, we see a 1. On the right, we see a plus c. So a plus c equals 1. And by this equation up here, we know that that means c equals 1. And finally, the constant term on the left is 1. On the right, it's b plus d. So we have b plus d equals 1. And from this equation up here, this means that d equals 0. So now we have our a, b, c, and d. Let's go ahead and plug in all of these into our expression over here in the top right. And I'm running out of room here, so let me go to the next page. So we have a was 0, so there's no x, and then b was 1. And then for the other integral, c was 1, so we'll have 1 times x, and then d was 0, and then x squared plus 1 squared. Let's go ahead and break this into two separate integrals. Now the first integral, you might remember this. So here you could, two ways to go about this one. Possibly the easier way is to just remember the fact that if you take tan inverse x, so this is something we've seen when we learned derivatives. If you differentiate this function with respect to x, you get x squared plus 1. So that means that the integral of 1 over x squared plus 1 is tan inverse x. If you forgot about this fact from differential calculus, the other way to evaluate this integral would be to do a trig sub. Here, x would be 1 tan theta. In either case, you'll get tan inverse x for the first integral. Now for the second integral, we should go ahead and do a u substitution. Let's take u to be the term inside the parentheses. And then we see du over 2 equals x dx. So we can rewrite this integral as 1/2 integral du over u squared. And we can use the power rule here. So this is just -1 over u. And then we can back sub u with x squared plus 1. So this is just -1 over 2 x squared plus 1. And so now we've evaluated both integrals. The last thing to do is to just add our answers together because of this plus sign up here that we're circling. So adding those together, the integral is just tan inverse x minus 1 over, then we have 2 x squared plus 1 in the denominator. And then don't forget that constant c of integration. And there's our final answer.